students, welcome to the channel. Our today's topic is waves. Wave is a commonly used word. Today we will discuss scientifically what the waves are. Students, we can define waves as the carrier of energy. Means waves are used for transporting energy from one place to another place. Waves are generated by vibrating bodies. Means whenever a body vibrates, it disturbs the medium around it, and this disturbance travels away from that vibrating body in the form of waves. So we call that vibrating body as a source of waves. Waves are divided into two categories. One is called electromagnetic and other is called mechanical waves. Our today's topic is mechanical waves. Students, these are the waves which require material medium for their traveling. For example, sound waves. If there is no air, means there is no medium, sound cannot travel. We cannot communicate with each other in vacuum. That is the reason we do not hear the sounds produced by the huge explosions that are taking place on the inside the sun due to nuclear explosions. We cannot hear the sounds of those explosions because there is a huge vacuum between earth and sun, and sound waves cannot travel through vacuum because they are mechanical waves. All such waves which require material medium for their traveling, they are placed in the category of mechanical waves. The other examples are water waves and waves produced in a string. These mechanical waves are further divided in two categories: transverse mechanical waves and longitudinal mechanical waves. First, we take what are the transverse mechanical waves. These are the waves in which particles of the medium vibrate perpendicular to the direction of propagation of waves. For example, look at this diagram. Here a wave is shown that is traveling to the right, and as the wave passes through the medium, particles of the medium are disturbed and they will start oscillating or vibrating. In case of transverse waves, these particles will oscillate or these particles will vibrate perpendicularly to the direction of motion of the waves. Here the wave is traveling in this direction and particles are vibrating perpendicular to this direction. This type of waves are called transverse waves. We can identify transverse waves by their pattern. They travel in crests and troughs. The portion of wave above the mean position, look at this half circle type shape, this is called crest, and that portion that is below the mean position is called trough. Crest and trough elevations and depressions are formed when transverse wave pass through a medium. So we can identify them by crest and trough. Crest and trough are the characteristics of transverse mechanical waves. Crest is the portion above the mean position and trough is the portion below the mean position. The examples of transverse waves are water waves. When we disturb a pond of water, we see a pattern like this that generates at the point of disturbance and moves away from it. So waves produced in water by throwing bubble in it are the example of transverse mechanical waves. Similarly, the waves produced in a string. When a string tied at one end is disturbed, this disturbance travels along the string in the form of transverse waves. Look at this crest and trough. Crest and trough travels along the string as the wave passes through the string. So these are the examples of transverse mechanical waves. Students, next group of the mechanical waves is longitudinal mechanical waves. These are the waves in which particles of the medium vibrate parallel to the direction of motion. Means the particles vibrate when wave passes through a medium, its particle vibrate. They will vibrate in a direction in which the wave is traveling. If wave is traveling in this direction, the particles will also vibrate parallel to the direction of traveling of the wave. Such waves are called longitudinal mechanical waves. They are identified by compressions and rarefactions. Compression is the portion of the medium where the crowding of particles takes place. Where particles of the medium get close to each other, that portion of the longitudinal wave is called compression. And rarefaction, where particles get apart from each other, that section of the medium is called rarefaction when a longitudinal wave travels through a medium. Look at this diagram. It is an example in which the longitudinal waves are traveling through a spring. Here the spring is compressed and here it is elongated. It is called rarefaction and it is called compression. The examples of longitudinal waves are sound waves. When sound travels through the medium, it compresses air and where the pressure releases the pressure, rarefaction is produced. So compression and rarefactions are produced in the air particles when sound waves travel through air. So sound waves are longitudinal waves. Similarly, waves produced in a spring. When we periodically compress and release a spring, a compression and rarefaction will alternatively travel across the spring. These are the examples of longitudinal waves. Again, I repeat it. Waves, sound waves, and waves produced in a compressed spring are the examples of longitudinal waves in which compressions and rarefactions are formed. So longitudinal waves travel in the form of compressions and rarefactions. Students, now there are specific terms that we use in the context of waves. First term is wavelength. What is wavelength? Students, when a wave passes through a medium, particles of the medium vibrate. Wavelength is defined as the distance between two consecutive particles which are in same phase of vibration. Means you can say that one complete crest and one complete trough is called wavelength, or from distance from one top of the crest to the other top, or one bottom or the lowest point to the other lowest point, which are consecutive points one after the other. This distance is known as one wavelength in case of transverse waves. Similarly, in case of longitudinal waves, the length of one rarefaction or one compression collectively is known as one wavelength, or one wavelength is the distance from center of one rarefaction to the center of other rarefaction, or from the center of one compression to the center of other compression. These distances are called wavelength and it is measured in meters since it is distance. Next term that we use is amplitude. Amplitude is defined as the maximum displacement of the vibrating particle from its equilibrium position. Here this height or this distance, that is from the equilibrium position, this is called amplitude. It is usually denoted with x naught. Maximum displacement from the mean position on either side is called amplitude. As we discussed in case of simple harmonic motion or vibratory motion, same is the case here because it is also the example of vibratory motion in which particles of the medium vibrate. Next is frequency, another term that we use with the waves. How much waves are generated by the source producing it in 1 second, or how much waves crossed a specific point in 1 second. That is called frequency. Means number of waves passing in 1 second through a particular point, or the number of waves generated in 1 second by the source is called frequency, and this depends upon source. Next is the time period. It is the time after which a wave pattern repeats itself. Means how much time it takes to produce one wave. That is called time period. And last is speed. Speed means how much distance a wave travels in 1 second. Distance moved by the wave in 1 second is called its speed. We can calculate speed by dividing its wavelength with its time period. When wavelength lambda is divided by time period t, we will get the speed of waves. Students, these are the basic definitions of the terms that are associated with waves. Students, thank you for sparing your time to watch the video. If you liked the video, don't forget to subscribe the channel. Take care of you.